Good day. Today we are going to discuss the simulation of cloud dynamics on graphics hardware. Overview of the research. The research introduces an interactive and visually pleasing cloud simulation that achieves physical realism. The model employs partial differential equation to represent various cloud aspects, including fluid motion, thermodynamics, buoyant forces, and water phase transitions. Additionally, the simulation accounts for light interactions, incorporating self-shadowing and light scattering effects. The implementation utilizes programmable floating point graphics hardware for dynamic and geometric simulations, optimizing scalability through flat 3D textures. To enhance real-time visualization, the simulation leverages the gradual evolution of clouds in calm condition, distributing computational tasks across frames for responsiveness in practical applications.
Research problem. The study focuses on efficiently integrating dynamically generated 3D clouds into existing applications. Researchers use a cloud dynamic simulation model based on partial differential equations and implement it with graphics hardware. The main goal is to reduce per frame simulation costs for real-time interaction. The research explores optimizations like amortizing costs over frames, efficient volume data representation, and realistic light interactions. The challenge lies in seamlessly incorporating 3D clouds into interactive applications while ensuring computational efficiency and visual realism.
Now we have the authors. First is Mark J. Harris. He works at NVIDIA Corporation, where it is an American technology company. He is a Doctor of Philosophy in Computer Science at the University of North Carolina. Second, we have William V. Baxter III. He works at OLM Digital Incorporation, a bachelor's degree in electrical engineering at Yale University, a Doctor of Philosophy in Computer Science at the University of North Carolina. Third, we have Thorsten Scherman. He is a graphics and engine programmer at Valve Software. He is a bachelor's degree and Doctor of Philosophy in Computer Science. Lastly, we have Anselmo Lastra. He is a professor of computer science at the University of North Carolina. Bachelor's degree in electrical engineering and a Master of Science and Doctor of Philosophy in Computer Science.
Terminologies. Graphics hardware refers to specialized electronic components, notably the graphics processing unit or GPU, designed for rendering and processing visual information. It is responsible for displaying images, graphics, and videos on digital devices. Light scattering is the process by which light changes direction or is dispersed when it interacts with particles or irregularities in medium, leading to the diffusion or redirection of the light. Fluid dynamics is the study of the motion, flow, and behavior of fluids, including liquids and gases, and their interaction with forces and boundaries. Buoyancy, in the context of differential equations, buoyancy is modeled mathematically as the upward force on an object in a fluid governed by equations that describe the fluid's behavior and the object's interaction with it.
Now let's move on to the governing equation of the research. We have the Euler equations of fluid motion. It is the partial derivative of u with respect to t is equals to the negative dot product of u and gradient times u minus 1 over p times gradient times p plus pk plus f. This equation expresses how the velocity of a fluid changes over time, taking into account advection, pressure gradients, buoyancy, and external forces. It is a cornerstone in the study of fluid dynamics and is used to model the behavior of fluids in various scenarios.
Wherein u is the velocity vector field of the fluid, indicating the speed and direction of fluid motion. P is the density of the fluid, B is the constant, K is unit vector in a specific direction, and F is the additional external forces or accelerations acting on the fluid. Wherein the partial derivative of u with respect to time t, this represents the partial derivative of the velocity vector field u with respect to time t. It describes how the velocity field changes over time, while the negative dot product of u and gradient times u, this term accounts for the advection or transport of the velocity field by itself. The dot product u and gradient is a convective derivative indicating how the velocity field u changes along its own direction. Negative 1 over p times gradient p, wherein p is the density of the fluid. This term represents the acceleration caused by the pressure gradient. It is proportional to the gradient of the fluid density p. Bk, wherein b is constant and k is the unit vector in the upward direction. This term represents buoyant acceleration, describing the effect of gravity on the fluid. Lastly, F again, this term represents other external forces or accelerations acting on the fluid.
And that concludes our short discussion about the research, the simulation of cloud dynamics on graphic hardware. Thank you.